Okay, let's get started with my mile to gallon to kilometers per liter converter solution. This is a solution to coding challenge number 1, and I'm going to walk through different ways that you could solve this problem. So just to recap, here is the challenge. Write a program that can take a number as input and return another number as output. It's assumed that the input number is miles per gallon and the output number will be kilometers per liter. The reason for this challenge is that one of the things computers do amazingly well is convert data from one format into another, and one of the sort of sciencey, mathy, ISATy challenges that you're likely to face in your coding career is doing conversions. So understanding units of measure, being careful not to mix them, all the things that go into solving equations on paper are the kinds of things you'll need to consider when doing them with the program. So the first step, whenever you're writing code, is going to be to plan out your solution. So let's think about it. Let's start by making sure we understand the math involved and how you would solve the problem by hand. So here you can see the formula for converting from miles per gallon to kilometers per liter. And you can see how the units cancel out, right? So if you multiply miles per gallon times kilometers per mile, then that converts miles to kilometers. And if you multiply 1 over gallons times gallon per liter, that's going to give you 1 over liters, and the resulting answer will be in kilometers per liter. At that point, then you can look up the relevant numbers that you're going to need. In this case, a mile is 1.609344 kilometers. And why did I choose a mile versus, to say 1 mile versus 1 kilometer equals however many miles? That's because that works out to a nice clean KPM value, right? Kilometers per mile value. Same thing for liters, right? 1 liter is 0.26417200524 gallons. And that works out to a nice GPL, which makes the equation nice and easy. All multiplication, multiply the miles per gallon times those two values, and we should get the kilometers per liter. And I've written this as a formula, right? You're used to in your other classes where you do, chemistry, physics, things like that, or even just straight up math, f of x. In this case, we're doing f of MPG, right? So it's a function. Your kilometers per liter is a function of your miles per gallon. In this case, it's a linear function because you could plot this on a linear graph where you put miles per gallon on, say, the x-axis and kilometers per liter on the y-axis, and you would be able to draw a nice line to show where the equivalents are. Next thing you might want to do is work some sample calculations by hand so that later on, when your program is running, you'll be able to know if your input and output is right. So just came up with a couple of numbers here. Started with 25 miles per gallon. So I multiply 25 times 1.6 times 0.0264 and get 2.6285926874 kilometers per liter. I did the same thing for 40 miles per gallon, comes out to about 17 kilometers per liter. And then I also went to Google and searched MPG to KPL, and it pops up a nice handy little calculator. And you can see here there are screenshots of typing those two values in, and you can see that the numbers that I worked out check out with Google. So at this point, I feel pretty confident that my math is correct and that I fully understand at least the underlying problem that I'm trying to solve. So what's next? After we've done the core math, we want to think about input and output. You can see here I've abbreviated that to I/O, and you'll see I/O a lot in computer specs and other sorts of technical jargon, but IO stands for input and output. The problem said write a program that can take a number as input and return another number as output. And you have to think about, okay, where is that input going to come from and where is that output going to go to? And here are several possibilities that would all satisfy that particular problem, right? You could prompt people from the command line, right? So on the command line, you could have a question that says, what's the MPG? And they could type it and hit enter, and then we could output the kilometers per liter right below it. We could make it so that when you run your program, you just enter the miles per gallon on the command line right next to the place where you start the program, and have that automatically be read in, have the answer calculated, and spit out at the end. Another thing you could do is you could make a GUI, right? A GUI is an acronym which is short for Graphical User Interface. And so you could make, a desktop program, or if you're using JavaScript, you could do it in a web page. You could throw in a form field that's just got, one text box that allows you to type in the miles per gallon, and then a button that says calculate, and then you could display the resulting kilometers per liter on the screen. That's more or less what this Google form does, right? You could read the data in from a file, right? Maybe you've got your data stored in a spreadsheet or a CSV, and you could write the output to a file, right, on the hard drive somewhere. You could read data in from a sensor, like in your car, right? A lot of cars these days have a fuel economy sensor that has a readout on your screen that tells you what the miles per gallon are, and output to the dashboard. And there are probably a bunch of other ways you could think about doing it, right? Input could be verbal, right? You could have some sort of speech-to-text recognition engine, and so you could talk to it, right? In the, like Alexa or some other sort of digital assistant, you could talk to it, and you could have the output come as audio, right? There are lots of different ways you can think about doing input and output, and the problem did not specify what the input and output formats should be. And so as a programmer, it's up to you to pick one, right? But the question is, which one is best, right? Which one should you pick? And this is a challenge faced by a lot of programmers, not just novice programmers, but experienced programmers, is getting paralyzed or caught by being faced with some sort of decision to make and not knowing what thing to do. Fortunately, there's some programming wisdom that can help us out, and that is that you should do the simplest thing that could possibly work. There's a link here to an article. It's a classic article, and you'll tell, the web page looks like it's right out of 1995, just plain text on a white background. In fact, this website, wiki.c2.com, is actually the very first wiki that was ever created by the people who invented the wiki. But this do the simplest thing that could possibly work is a bit of programmer wisdom that's been passed down through the ages, and is a really good place to start, regardless of whether you're a beginner programmer or you've been doing this for a long time. You could really shoot yourself in the foot by starting off with something that's way more complicated than you need. So what is that in this case? What is the simplest thing? My guess, right, my estimation is that the easiest thing is either to prompt users to enter the data on the command line, or read data in as an input parameter. One of those two things. I'm actually going to do something even simpler on my first iteration, which is just to hard code the number. But that doesn't really satisfy the problem, because it does say that there should be some sort of input as well as output. Adding a GUI would probably involve a bit more work in this case than just doing one of the two things I referred to above. If you want to install this in a car, you're going to have to hack your car to be able to calculate fuel efficiency, and who knows if that's even possible with most cars. It might be, but I certainly don't know how to do it, and it's definitely not the simplest thing. Reading from a file is not too tough, but it's probably overkill in this particular case. And a good rule of thumb is just to start with the thing that seems the most intuitive, logical, natural, or whichever one just seems easiest to you. You might find out that it's not the easiest thing, but at this stage of the game, when you're just getting started with your career as a programmer, you have to be comfortable with a fair bit of uncertainty. You have to be comfortable with the idea that it's just going to take you time to read documentation, to watch tutorials. You're going to have to, that knowledge doesn't come from nowhere, and there's nothing I can say or do that will make you just suddenly know what the best thing is. You got to put the time in. You got to watch the videos, do the tutorials, read the documentation for the various programming languages, so that you can implement a solution. Some things I want to note about what we've done so far is nothing we've talked about so far is specific to any particular programming language. Right? I did mention web pages and JavaScript at one point, but really these principles, the things I've talked about so far, are going to be universal to writing code to solve a problem in any language. You still want to make sure you understand the math and the problem that's being solved before you actually get into doing code, and you want to think about what are all the pieces that I need to consider, right? Another thing to maybe note is it's really easy, it's very easy to start adding unnecessary features like a GUI, or start thinking about incorporating this into a car or reading from a file. Things that are cool, absolutely cool, and things that might be seemingly fun and interesting and motivating to you, but it's really easy to shoot yourself in the foot by biting off more than you can chew, and then you're not able to hit whatever deadline that you had set for yourself to finish a particular program. Like I said a second ago, there's almost always going to be a lot of uncertainty. For example, if you've never written a program, how are you supposed to know what the simplest form of I/O is? And we haven't mentioned anything about what to do if things go wrong. For example, what if you have a form, or ask a question at the command line asking people to input the miles per gallon and they don't input a number, right? What if they type a word or do some other thing that's unexpected? How do we handle those things, right? So there are always going to be ways that we can augment, improve, iterate on our code. So let's get started. The general approach in a case like this is to create a new project, set up your development environment, then you're going to write the simplest program that actually works, and then you're going to iterate to make it better. In this case, better means that you've got good documentation, that your files are organized well, that the code is organized well and it's nice and clean and linted, and we'll talk about that maybe not today, but in the near future. It's a really extremely good best practice to add unit testing to your code, and then to do some error checking and exception handling. I'm going to do this video in two parts, so there'll be a Python version and a JavaScript version. I encourage you to watch both of them so that you can compare and contrast what things are similar about coding in each language and what things are different about coding in the languages. In both cases, it's important to know that there are some significant features of this program that I, at this point in time, don't know how to do off the top of my head. So I'm going to have to research them and read some tutorials or articles or documentation or something that will help me find out how to do the things that I want to do. I'll do my best not to wander off into tangents trying to explain too much detail things that you don't need to understand right this second, but I hope you'll get a lot out of watching me solve this in a way that will help you begin to write your own programs, and write programs not just about challenges issued by me, but things that come from your own brain, that come from your own heart, that come from your own interests and help you solve problems that you care about. Okay, so let's get started with the JavaScript version of this project. The first step is to be able to create a new project and environment. Last semester, I created a slide deck, which you can get to at slides.com/morephatic, called How to Start a New Project. And in here, I have notes on how to start a new project. A lot of times when you read tutorials and watch videos on YouTube on how to do things with programming, the underlying reason why a lot of this stuff gets there is because the programmer, somebody like me, wants to create a way to remember how to do this stuff. So I knew I would forget, and so I created myself a nice little tutorial. So the steps are going to be to create a GitHub repository with description, readme, and git ignore file. Then clone it to my hard drive, initialize the development environment, set up TDD, which stands for Test Driven Development Tools, write and run a smoke test. I'm not going to do this today, nor are we going to follow a TDD process. I will be talking about that in the upcoming weeks, but it's a little too soon yet for us to start doing things that way. And then add, commit, and push frequently. Again, this is referring to Git and GitHub. So there's notes here on how to do this with Python, and then there are also notes on how to do this with JavaScript. So first thing I'm going to do is create a GitHub repo with a node git ignore. So let's go, here's my GitHub. I'm going to go up to the plus sign, click new repository, and I'm going to call this MPG to KPL -JS, and this is a miles per gallon to kilometers per liter converter in JavaScript. I'm going to click the checkbox to add a readme file, and I'm going to click the checkbox to add a git ignore, and down below I'm going to type node, N-O-D-E, and choose node. I don't really need a license for this one, so I'm going to go ahead and click create repository. And now that it's created the repository, I'm going to go up to this green button that says code. I'm going to click on it, and then I'm going to click this little clipboard icon to copy this URL to my clipboard, and then I'm going to go back to my terminal, and you can see here I've just opened up my terminal, and I'm going to cd into my development folder, dev, and then I'm going to type git clone and paste in that URL that I just copied. Now note, if you're on Git Bash on Windows, you might need to learn a different set of keyboard shortcuts to paste than you are normally used to. Just Google for that and you should be able to find out what they are. I don't think that the standard like Control-C, Control-V works in Git Bash. Alright, so that has cloned that. Now I can cd into that directory, MPG to KPL-JS, and I can open this up with Visual Studio Code. Just type code and dot. Dot is a shortcut which refers to this directory that I'm in right now. In other words, the MPG to KPL-JS folder. Hit enter, and that will open up Visual Studio Code. And you'll see here, right, that the readme.md file that was created for me by GitHub is here. And let's just go in and change the name of this to MPG to KPL converter in JS. And we've got the description down here. And later on, I can come in, I can, write a little a journal entry or something to record my process, but I'm gonna go ahead and save that and close that. now I'm going to open up the terminal that is inside of Visual Studio Code, and there's 3 different ways you can do this. You can use the keyboard shortcut, which is to hold down the Control key and then hit the backtick. Backtick is the key directly to the left of the 1 key on your keyboard, and you can see that will open up the terminal down here. You can use that same keyboard shortcut to hide the terminal. Second way to do it is to mouse over the status bar down here and drag up. That's another way you can open up a terminal. You can close it with this little X. And then the third way to open it is to go to the View menu and select Terminal, right? And that will also show this. I'm gonna maximize this, and now I'll be able to access the terminal directly from within Visual Studio Code, and this is probably the most convenient way to get your environment set up. Now you'll notice here that in this little drop down, it lists which terminal I currently have open. I'm using something called Z Shell, but you should either be using, you can either have this if you've installed iTerm with Z Shell, or you'll want, if you're on a Mac, you'll probably have one that says Bash, B-A-S-H, and if you're on Windows, you'll definitely want this to say Bash. Now, by default, Windows might have CMD or PowerShell as the default shell here. You can change that by clicking on that and click this menu choice here to select the default shell, and that'll create a drop down up here where you can select from the available installed shells on your computer. I don't want to change my default shell, so I'm just going to hit escape to escape out of there. But you can create like another tab in your terminal by clicking the plus sign. And now if I click the drop down, you'll see I've got 2 of them. They both have the same content in them right now. But if you want to get rid of one, then you can hit the trash can icon and that will get rid of it. Cool. All right, so let's go back to our steps here. And we created GitHub node with a git ignore file. We've cloned that to our hard drive and we've CD'd into the directory. Now we need to initialize a new node project. So in order to do that, we're going to type npm init. Now it says answer jest for the testing command, and like I said earlier, we're not going to be doing testing today, but it's not a bad idea to get in the habit of doing this. So I'm going to set it up for testing, but we're not going to actually do the test-driven development style today. So here from my terminal, I'm going to type npm, which is short for Node Package Manager, init, which is short for Initialize. And it's going to walk me through a process. It's ask me about a bunch of questions. Now, if you start at the top, it says this utility will walk you through creating a package.json file. It only covers the most common items and tries to guess sensible defaults. You can type npm help init at the command line for definitive documentation on the fields and exactly what they do. Use npm install and then a package name afterwards to install a package and save it as a dependency in the package.json file. So package name, in this case, they've guessed basically the name of the directory, MPG to KPL. If I want to just accept this, I can hit enter, but I want mine to include the JS part. So I'm going to type MPG to KPL JS. The version 1.0, that's fine. Description, since this is just a simple program for yourself, you don't really need to type this in, but if you want to be consistent about documenting stuff, you could type MPG to KPL converter written with JavaScript. The entry point index.js is just fine. The test command, like I said a second ago, you'll probably want to type jest. And then you'll see here that it automatically, since we cloned this from GitHub, this npm init command is able to automatically associate this project with our GitHub repository. So I'm going to go ahead and enter there. Keywords makes your package searchable if you eventually end up uploading it to where it can be distributed to the world. We're not going to be doing that, so I'm going to skip the keywords. author. You could put your name here or your email address if you want this package to be associated with you. Like I said, we're not going to be distributing this to the world, so it's not super critical that you fill in the author. Also, license. This is not, since again, these questions are mostly focused on packages that are going to be distributed as open source software to the world, and we're not going to be doing that, so the license is really not that critical. So it's going to show you all of the things that you just selected in one big list, ask if it's okay, and you'll say yes. And when you do that, you'll notice that you've got package.json file that shows up here with a little U next to it. It's green. And what this is saying is that this is a new file that Git is noticed that you've created, and as of yet, it is untracked. That is what the U stands for, untracked. If you click on it, you'll see, the name that you had just typed in. You'll see the description that you just typed in, the version that you selected. The index.js is the main file. Your testing command and all that other information is stored here. You can leave. You're not going to need to mess with that, but just leave it there. Here next to readme.md, you can see there's an M. M is for modified. That's because we opened up that file and we changed the title for the project. Okay, so we've done this, and now it says set up testing. And to do that, we're going to install an npm package called Jest, J-E-S-T. So I'm going to type npm install --save-dev jest. Do that from the command line. npm install --save-dev jest. What this will do is this is going to go out to the web, and it's going to get a third-party package called Jest, which is software that was written by Facebook actually for testing JavaScript code. We're not going to be testing our JavaScript code today, at least not in the formal sense, and so we're not going to be using this for this particular project, but in the future we'll definitely be learning how to test our code. So it's good to get into the habit of installing this, and I want you to get used to what happens when you install a package. Okay, now that that's done, you'll notice a couple things have changed in our repository. First of all, there is another new file called package-lock.json. This is also untracked. And then there's also another folder here called node modules. If you're paying close attention, you'll notice that node modules, the name is grayed out. That's because in our git ignore file, we've said that we want to ignore, where is it? We've told Git that we want to ignore the node modules folder. And that's good. You definitely want to ignore that. Otherwise, you would have to upload all the files and folders that are in here, and there are quite a bit of them now. You would have to upload all those to GitHub, and you do not want to have to do that. You should never, ever have to modify or even really look at the files in the node modules folder. So you can just basically ignore that that's there. Don't delete it, but you can ignore that it's there. You'll also notice if you open up package.json and scroll down to the bottom, a new section has been added, which has as a development dependency, dev dependencies, Jest version 26.4.2 has been installed in this project as a dependency. One more time, we're not going to be doing testing today, but in the future we will use Jest for that. And that's what it looks like when it's installed. Okay, so at that point, we want to do our first commit. Now you're going to want to go through this process of committing your code frequently throughout the process, so you can make sure that if your computer dies for some reason, if your cat throws up on your computer in the middle of coding, you'll lose as little code as possible. So here in my terminal, I'm going to type git status, and it's going to show me a few things. First of all, I'm up to date with origin master. Origin master in this case refers to the copy of our repository that's on GitHub, and we're up to date with that. So everything that's on the remote repository, we've got that here locally. But we've also got some changes that have not been staged for commit. The changes are the readme.md file, which we modified, and then it's also got these two untracked files. You can tell by the U, right? M for modified and U for untracked, package lock.json and package.json. Package.json basically has the list of packages that are dependencies of this project. Package lock.json has got a whole bunch more detailed information, and you should never have to open or modify that package lock.json. But it's important, don't delete it, but you don't have to modify it either. In order to add these files to the list of files that are tracked and that we want to commit, we need to first do Git Add. So let's do Git Add. Now, one way we could do it is we could do them one by one. Git Add Readme, package.json, and package lock.json. We could type all the file names in separately, but a much faster and easier way to do that is Git Add dot. Again, dot is a shortcut that refers to this directory that we're in right now, and doing Git Add dot will add all of the changes that we've made to the list of things that we'd like to commit to our repository. Once I've done that, I'm going to type git status again. And when I type git status, you can see now all those things that were in red have changed to green, and it says you've got a modified readme and you've got two new files, package.json and package-lock.json, and they are ready to be committed. Now, they have not been committed yet, but they are ready to be committed. They are what we would call them staged for commit. So now that they're staged, let's actually do the commit. So we're going to do git commit -m, and then we're going to type a commit message, and we're going to finished project setup. The commit message should be short, 2-3 words at most, maybe 4 or 5, but not more than like 50 or 60 characters, in which you want to explain or summarize the changes that you have just made and that you're about to commit to memory or commit to your repository. That should be so that you can come back later and you read the list of commit messages you made. You can see all the tiny steps that you took as you were developing your project. Okay, so it's going to say 3 files changed, 4,699 insertions. These are basically just statistics that have to do with those files that we just added. You'll also notice that the file name went back to being just plain white. Plain white means it's a part of this repository, and it's not a new file, it's not a modified file. There and ready to be changed if you want to, but it has not been changed in any way. Now, at this point, I've committed the changes, but the changes are still only on my local machine. They have not been shared with my remote repository on GitHub. In order to do that, I need to type git push to push them up to the remote server. And once I do that, now if I type git status, it will tell me that I'm on the master branch, right, which is this one. My branch is up to date with GitHub. That's what origin master refers to, GitHub. And I have nothing to commit. My working tree is clean. All right, so at this point, I'm ready to start working on this project. And this says begin the TDD process. Like I said, we're not doing TDD today, but we will do that soon. All right, back to here. Write the simplest program that actually works. So let's do that. I want to find that formula for MPG to KPL conversion, and I want to just grab that formula. So I'm going to grab this much of it, copy that. I'm going to go back and I'm going to create a new file. A couple of ways I can do that. you can click on the new file here, and I'm going to call this index.js. If you're writing a simple project that only has a single JavaScript file in it, the convention, the sort of most common name that people give to that is index.js. So that's why you'll see that in a lot of projects. There's a lot of reasons, there's a lot of tools and things that will check to see if that index.js is there, and we'll get some important information out of it. Probably not for this project, but in the future, right? It's a good rule of thumb to just name your project index.js, or name the core file in there. And you'll see now it's green, it's got a U for untracked, and what I want to do is I want to do the simplest thing that could possibly work. So let's add a comment that says the simplest version that could possibly work. And I'm going to do console.log. I'm going to paste that formula in there. I'm going to get rid of the KPM because you don't want to have units like that in your code. And then I'm going to type 25. And I'm going to say output the result of converting 25 miles per gallon to KPL. I'm going to save that, and then I'm going to go down to the console here, and I'm going to type node index.js. And you'll see that when I do that, it outputs 10.62859. If we go back and look at our slides and look at our sample calculation, 10.62859, etc., etc., we are getting the right answer. So at this point, I guess you could maybe argue that we're done, right? We've got a program that does the conversions that we're talking about doing, but I would probably say no, we're not done yet, because if you look at the original problem, it says write a program that can take a number as input, and we don't really have that. I mean, I guess you could consider this bit here to be input, but this would be a really crappy program. Every time you wanted to do a calculation for a new number of miles per gallon, you would have to like open up the code, change the source code, save it, and then run it again. And that obviously is not very user friendly. So let's update this to be a little bit or a lot better, right? And so what we're going to do is we're going to move this stuff, open up a few lines here. I'm going to start by creating some documentation at the top of my file. Now you'll notice here that I did /** and then I hit enter, and it automatically created this sort of like multi-line comment structure for me. This style of comment is extremely common, and there are tools built into Visual Studio Code which help you type them. At the top of your file, it's customary to put a bunch of metadata about your program. So in this case, it's common to start with the name of the file or the module in this. And so this is index.js, and then this is a program to convert miles per gallon to kilometers per liter with input taken from the command line, because I think that's what I want to do here. So let's modularize this program a little bit. I'm going to give ourselves a little bit more room to code, and I'm going to start by declare useful constants. And so I'm going to say const, use the const keyword, and the first one I'm going to do is kilometers per mile. And I'm going to say kilometers per mile equal to this value, right? Because this is the value we had for kilometers per mile. And I'm going to put a comment at the end of this line that says kilometers per mile so that we can remember what it is. And then I'm going to create another constant, and this one is going to be gallons per liter, and that's going to have this value, and I'm going to call that gallons per gallons per liter. And just for the sake of making it easier to read, I'm going to line up those two comments, right? So they're vertical, and the goal here is to make this code easy for either for you or for somebody else who happens to open it to, at a glance, go through and know what all these things are, right? If you've just got these two random numbers here, who knows what those are, right? I doubt there are very many people in the world who know that they see 1.609344 and they think, oh yeah, that's kilometers per mile, or 0.2641720.524. Think, oh yeah, that's gallons per liter, right? Those are not common numbers. So we'll do better to create those as constants in our program that are well named and well labeled, so that when we use them later, it'll make sense. And now we want to create a function that converts a given MPG value to KPL. And this is a function that takes a parameter that is a number. I think actually I want to put that in square brackets, number. And we're going to call the parameter that is taken in MPG. And then it returns also a number. And I like to line these things up. So the miles per gallon value to be converted, and it returns a number which is the kilometers per liter. All right, so all this stuff I've done up here, this is all because it's between the the slash star and star slash. That's all documentation. These are comments. This is a special form of comments called JSDoc. These could be converted into documentation for your program, like in the form of a website that people could click through. We're not going to do that for this program, but it's a good idea to get in the habit of documenting your stuff, right? So now we'll actually write the code, and this is going to be a function, so we're going to use the function keyword, and the function is going to be MPG to KPL, and it's going to take as a parameter a value MPG. Okay, and then what it's going to do is it's going to return MPG times KPM times GPL. And now that we've written that function, now we can go down here and we can rewrite this console.log MPG to KPL, and we can pass in 25. Now if I save this and run it again, we get the same response. If we change this to 40, save it, run it again, 17.0057, 17.0057 stuff. So okay, so this is working now. All right, so now we've made it a little bit cleaner. Now we want to get it so that it actually asks the user for a miles per gallon value before it converts it. To be honest, I don't know if I've ever done requested user input directly from the command line in plain old JavaScript. I've used some tools for it in the past, but I don't know how to do it. So I'm going to show you my process about how I would go about learning how to do this, so that you can do something similar when you write your code. All right, so in here I'm going to Google how to prompt a user in JavaScript. And I'm just going to put console in here. How do I get console input in JavaScript? And here's another tutorial on dummies.com, how to prompt the user for input in JavaScript. This one looks like, just looking at the screenshot, it looks like it's supposed to do that inside of a web page. So I know that this one is for the console or the terminal, so I'm gonna click on this one. Stack Overflow, you may or may not know, is a question and answer website. This is probably the #1 place that programmers go to ask questions and get answers about code. And so this person says, I'm currently using SpiderMonkey to run JavaScript code. This was posted in 2010. So this is a 10-year-old question. You definitely want to check out how recent these questions are when you do this stuff to make sure that you're getting a good answer. I'm currently using SpiderMonkey to run my JavaScript code. I'm wondering if there's a function to get input from the console similar to how Python does raw input, or in C# they do this. I've looked around, so far I haven't found anything. Good old readline. So this person put a link to that in the documents, and you can see 45 people found this helpful and they upvoted it, and 14 people found this one. This answer was from 2010. Here's another answer from 2016. In plain JavaScript, use response equals readline after printing a prompt. In Node.js, you'll probably need to use the readline module. It's usually not a bad idea to read through multiple responses on here. If there's more than one answer, it's not uncommon to see somebody has checked one answer is correct, but the actual most popular answer comes down below that. And also these comments can sometimes have useful information. So when you're using Stack Overflow, don't restrict yourself just to looking at the first answer. Particularly this one is related to SpiderMonkey, and that's an old thing from a really long time ago. And you may not know that being new to JavaScript, but this one is a little bit clearer. As you mentioned, prompt works for browsers all the way back to Internet Explorer. Prompt, that's for doing it inside of a browser, not at the console. For Node, you can use console read write, which is wrapper around the low-level readline module. So this is an external package which you can use to do this. You can try something like process.argv. So let's go back to this one, response.readline after printing a prompt. So I'm looking at these responses down here. Var x equals readline, type error, readline is not a function. After adding require at the top of the file. Also had the same problem. That's weirder than ever. Readline does not work the same in Node. You need something like this, constant readline equals require readline. All right, let's take a look at this documentation. So this is Node.js. This is version 14. If I go back to my terminal and do node -- version, I'm using version 12.16. So let's see if we can change the version. View another version, 12.x, that's what we have. All right, so I'm gonna do Command F to find readline. And it looks like readline, okay. Gotcha. So let's scroll down and see if there is just some sample code that shows us how to do this. The readline module provides an interface for reading data from a readable stream, such as process.standardin, which is the command line, one line at a time. It can be accessed using const readline equals require readline. The following simple example illustrates the basic usage of it. So we put this at the top of our file, and then we use this create interface to create, I guess, an interface to the command line. And then you can do rl.question and then have a response come to that. All right, so let's try this. Go back to my code, and I'm going to go back up to the top here, and I'm going to create a section which is import necessary tools or packages. And to do that, I'm going to const readline equals require readline. Now it's important to grasp this works with Node.js, but this way of doing it is not going to work in the browser. There's a different way. If you were doing this in a browser, you'd have an HTML form and you could read the values out of the form. But since we're trying to do this from the command line, we're gonna use their way of doing it for that. Okay, so now that I've imported this, we want to create a readline interface. So in this case, we're going to do const, and they used RL, which is, I guess, useful enough, equals readline dot. And you can see here when I type the dot, because Visual Studio Code understands JavaScript and particularly Node.js, it's got the create interface right here. I can just click create interface, and it will allow me to then specify the input and output interfaces. And so let's do that. It's an object with input process.standardin. So curly braces, then inside of this, so we're going to do input process.standardin, and then output is process.standardout. Okay, so that creates our readline interface. Now we've declared our useful constants. We've converted got a function to do the conversion. And now we want to go down here and we can get rid of this stuff down here. Now we're going to say RL dot, what was it? I can't remember. Question. And we can say enter the MPG value. And then we want to put in a function to handle the result. In this case, we might be able to do it this way. We can just MPG to KPL. Will that work? I don't know if this is going to work. Let's try it. I'm going to save that and do node index.js. It says enter the MPG value. I'm going to type 25, hit enter, and nothing happened. Okay, well, we at least got the questioning part, right? Hit enter a few times, nothing happens. All right, if you get stuck like this in a running program, Control-C is usually the thing that will get you out of it. All right, let's try it the way they did. So we're gonna put parentheses, and we're gonna say MPG they're using a fat arrow function that looks like this. And then we should be able to get access to that value. So let's try console.log MPG to KPL MPG. And then we want to do rl.close the same way that they did. And you'll notice here that when you read other people's JavaScript, a lot of time they have semicolons at the end of their lines. I may have mentioned this in a previous video, but most of the time, not all the time, but most of the time those semicolons are optional, and I tend to leave them out. So if you had a question about that, then most of the time they're optional. There's only a couple of instances when they're not. If you're in doubt, it's fine to add one. Okay, so let's try this again. Enter the MPG value, 25. Hit enter, and look at that. It does the value. Let's do this again. Let's try 40. Okay, so now we've got a program where we can enter in any value. Let's say you got 50 miles to gallon. That's 21.257. Now this number that comes out is maybe not super user friendly, right? Let's say, for sake of example, that we maybe wanted to round this number down, right? How would we do that? So let's take a look at, I'm gonna close these other tabs that we opened here and look how to round a number to 2 decimal places in JavaScript. JavaScript toFixed method. Round to at most 2 decimal places only if necessary. Let's take a look at that. In JavaScript, if you've got a number, if you've got a numeric value, you can just do toFixed and put the number of decimal places you want. One of the things I like about W3 Schools, if you click this Try It Yourself button, it'll open up a new tab, and it'll have a place where you can edit code on the left, and then a button where you can click Try It, and it'll do what you want here. So, you know, we could change this number to 789, and then click Try It again, or Run. If you've changed this code, you have to click Run, and then you can click Try It, and you can see here that it rounds to 2 places. Or if you want to round to 1 place, now you can see 5.8. So take a number and say toFixed, and then do that. So we should be able to do, since the thing that gets returned from this function is a number, right? We should be able to just put a dot at the end of that and say toFixed and add a 2. Save that. Now if we try to run this again, 25, 10.63. Now there's another interesting thing here, right? This value is yellow, this value is white. I'm not exactly sure what that is, but my guess is that there's some subtle things happening in here. Let me also show you something else. If we do enter this, and what if we type 25 MPG? The result we get here is NaN, which is not a number. So essentially, this MPG to KPL function is expecting MPG to be a number. If it's not a number, then it doesn't know how to do the calculation. When we typed 25 space MPG, it tried to take that and use it in this equation. And obviously it doesn't know how to multiply letters by numbers. And so it's going to choke and die on us there. Okay, so we're not going to do any sort of error handling or error correction, but if you want to go and do some of that, work on doing some of that yourself in your programs, I highly recommend that you dig into that. I'll be showing some more structured approaches to that later on in the semester. Okay, so now let's take a look at what we've got here. We've got documentation, which is our program. We imported a tool called readline, which allows us to read input from the command line. We configured it, and this basically says standard in and standard out are usually the command line. And we just said that's what we wanted our input and outputs to be. Now, theoretically, you could have set this interface to be to like a file. And so the input, it could read a line of a file. The output could be to a file. So it might, write a line to a file or something like that, right? So there's probably a variety of ways that we could use this, but we're just using this standard way. We created some constants, right, which should be relatively straightforward for people to understand. Then we created a function that does the conversion. And again, we did not check to make sure that this was a number. And if you pass something in that's not a number, it's going to blow up on you, but we'll do something about that later. And then we've got, right, prompt the user to enter a value. Then after they do that, take the entered value and output the converted value, and then close the interface. All right, so just added a few more comments in there to make sure that it's working. All right, at this point, I want to do git status. Now that I've added those comments, I'm gonna run it one more time just to make sure it's still working. We'll add, say, 40, 17.01. Okay, that's good. All right, I'm gonna run git status to see what our status is. It says we're up to date with the GitHub. We have an untracked file, index.js, and yes, okay, that's green. It's got a U for untracked. That means we need to add it to the list of things. So we're going to do git add index.js. And now you see that U changed to an A for added. All right, now if I do git status, it'll say it's gone from red to green. It says it's a new file. So now we can commit it, git commit-m. Takes user input. Now, right before when we committed it, it didn't take user input. And now if I do git status, you'll see that we're ahead of GitHub by 1 commit, and we can use git push to publish our local commits. So let's do that. Git push. Okay. And so now our GitHub should be refresh, up to date with our local version of the repository. So we've got the index.js, which has got our code in it. We just added that 30 seconds ago. The other files like Readme were updated half an hour ago. Now one thing we might want to do is we want to add our screenshot in here. So I'm going to go back, and I guess I could do it in here. I'm going to do it from this terminal just because I think it's prettier. So I'm going to do clear, and I'm going to resize this. And I'm going to type node index.js. It's going to enter miles per gallon value, let's say 25. And it's going to give the result. If you're on a Mac, this is built into the operating system. Shift Command 4 will make your cursor into crosshairs, and you can drag it around to record to snip some part of the screen, or if you hit the space bar, it will allow you to get a screenshot of the current window that you're using. And so took a screenshot of that, and I'm going to, if I click here to open up my Finder, and I'm going to go to my dev folder and find that MPG to KPL.js. So this is the project I've been working on. I'm going to go click on here, find that screenshot that we just did, and drag it in there. Then close those guys up. So I just put that screenshot in here. I'm going to rename it. We're going to call it screenshot1.png. And now if I go back to Visual Studio Code, it'll show up as an untracked file. And if I click on it, it should open up in here just like that, right? So you can see that. And I'm also going to go open up my Readme and update this. Here is a screenshot of my working program, and the way you add this in Markdown is an exclamation point and MPG to KPL converter screenshot. This is a label so that people who are using screen readers or otherwise can't see the picture can get can know what it is. And in here then I'm going to put the file name screenshot1.png, and then at the end here I'm gonna add a subheading and put in here some thoughts about this process. The hardest part about this project was figuring out how to get user input from the command line. I'd never used the readline package before. The documentation was relatively straightforward, but it assumed that I had some experience with Node, which I didn't have before this, and that made it more difficult. Right, so in general you might want to add some stuff in here. You can see I get little yellow squigglies here. That's a stylistic problem. It's saying that I should never increment. So I had a level 1 heading here, and then I have a level 3 heading here, and they want me to use a level 2 heading. They don't want me to jump from 1 to 3, and that's fine. I guess I can do that. All right, now if I save this, if I want to preview this, you can actually preview your readme.md file right in Visual Studio VS Code by clicking on this preview, and you can see it's got the image, it's got the title, and then it's got my thoughts right in here. I'm going to close this preview, and then I'm going to go down to here and say git add dot git commit -m added screenshot and thoughts, and git push. Okay, so now anybody who shows up at my repository can see a screenshot, right, which is pointing to this file that's right here, and they can read my thoughts on what it was like to do this. All right. So we wrote the simplest program that could actually work, right? Remember the first iteration we didn't allow the user to enter in a number. And then we went through a number of ways, like a number of revisions to make it better with better documentation. We organized our code better and our file better. We did not do unit testing this time, but we will start doing that later on this semester. And we didn't do any error checking, although we did see how this could go wrong if somebody entered anything besides a number when they typed in their value. Okay, I'm going to close it off there, and if you have any questions, of course, please ask them in Slack, and I'll be happy to answer them.